Now we look at chapter 15, which is redox reactions. You can just pause this page and have a read of the points here. What you need to remember is oil rig, oxidation involves loss of electrons, reduction involves a gain in electrons. You need to know what an oxidizing agent is, what is a reducing agent, and be able to identify it in any reaction. Now we look at writing of balanced redox reactions. Okay, we're looking at question 1. I'll give you a moment to just read and understand question 1 before we work on the solution. Okay, now the oxidation of reaction, which is part A of the question, is Fe2 plus goes to Fe3 plus an electron. Remember, oil rig, oxidation involves loss of electron. So if there's a loss of electrons on your left hand side, it occurs as a gain of electrons on your right hand side. That's why there's plus 1 electron on the right hand side. Okay, next we look at part B, the reduction of reaction. We got MnO4 minus is going to Mn2 plus. Okay, we notice that there's one manganese on the left and there's one manganese on the right, so there's no need to balance the manganese because it's balanced. We look at oxygen. There's 4 oxygens on the left, there's nothing on the right. So to balance the oxygen we can use water. Now if I add water, I need to have 4 waters because there's 4 oxygen on the right and I'm aiming for, there's 4 oxygens on the left, I'm aiming for 4 oxygens on the right. And I've now introduced hydrogen. I've got 8 hydrogens on the right, so I need 8 hydrogens on the left. Right, now I'll look at the charges. I've got minus 1 charge and an 8 plus charge. That gives me plus 7 on the left, and on the right I got plus 2. So there's a difference of 5. So I can add 5 electrons on the left and this equation will now be balanced. That is, I have 2 plus charges on the right and I've got 2 plus on the left. Okay, now we look at the overall reaction. Now for the overall reaction, I need to cancel out the electrons on the left and electrons on the right. And to do that, you can see that equation 1 has got 1 electron, while equation 2, that is equation B, has got 5 electrons. So I need to multiply equation A by 5. Okay, once this is done, I can add the green equation, which I've just multiplied by 5, and equation B together to get the overall equation. Remember, I can just cancel off the 5 electrons because it appears on the right and left, and I can just copy down everything else. Just one more thing, don't forget to include the states, because the states, if the states are asked in an equation or question, you have to include the states to get full marks. Okay, the next question is also very similar to the first one. We're looking at magnesium to Mg2 plus and dichromate to Cr3 plus. Like in the previous example, the oxidation of reaction, you got magnesium solid going to Mg2 plus. Remember, oxidation involves loss of electrons. We show it on the right hand side of the equation as a gain in electrons. You're looking at the magnesium, there's 1 mole on either side of the equation. And the charges are actually balanced. There's 0 charge on the left and there's 0 charge on the right. Okay, next we write down the reduction of reaction. We got Cr2O72 minus going to Cr3 plus, but we have to add 2 in front of the Cr3 plus so we can balance the chromium on either side of the equation. Now looking at the equation, we see there's 7 oxygens on the left. We need 7 oxygens on the right, and we can only do that by adding 7 moles of water. Okay, we now need to account for the 14 extra hydrogens added on the right hand side by adding 14 H plus on the left hand side. Remember, when adding for oxygen you add water, when accounting for the hydrogen you need to add H plus. Okay, next we have to look at the charges and try and balance the charges. We've got a plus 12 charge, that is 14 plus and 2 minus on your left hand side, and we got plus 6 on the right. So effectively we got a plus 12 on the left and plus 6 on the right. There's a difference of 6, so I need to add the 6 electrons, and I'll have to add it on the left hand side. And like we did in the previous question, we just continue to try and balance out the redox reaction. So by balancing it out, we mean we need the same number of electrons on equation A and B. So I need because I got 6 electrons on the left hand side of B, I need 6 electrons on the right hand side of A. So equation A I can multiply by 3, and then we are done, and you can follow the working from there. So the green box represents the overall balance redox reaction. Also note that all the states and stuff have been included, and as last check you look at each element. Magnesium, there's 3 on the left and there's 3 magnesiums on the right, etc. Make sure there's a total balance, and also remember that the oxidant is Cr2O72 minus because it is reduced to Cr3 plus, and the reductant is Mgs because it is oxidized to Mg2 plus. Okay, if you're not sure of that, go back to page 1 and have a look at the definitions. Now we're moving on to the next questions, or the next topic, oxidation numbers. What is the oxidation number of chromium in potassium dichromate? Potassium dichromate is K2Cr2O7, right? Potassium, because it's a group 1 metal, potassium is +1 always, and oxygen will take on a -2 charge generally in most cases. Okay, so that's the first thing, and once we got that, we look at the charges, balance it out, and chromium must take a chance to balance the entire compound. Okay, so let's have a look at the solution. Potassium is +1 because I've got K2, so that gives me a charge on the K part of +2. Oxygen, each oxygen is -2, and because I got 7 oxygen, that's going to give me -14. So that overall it gives me a -12, right? So chromium has to be a +6 to get a +12 and balance the compound. Yeah, there was a slight error there. The potassium dichromate is actually K2Cr2O7, so you'd understand that better. Now looking at question 4, what is the oxidation number of manganese in KMnO4? Again, oxygen is a -2, potassium is a +1, and then we try and put the numbers together and see what charge manganese must take to balance it out. Okay. Now we are done with oxidation numbers, so I hope you follow it from this screencast, and it becomes more clearer to you. So if you're having a problem with redox reactions and oxidation numbers, I suggest you look at your textbook and try and work out more examples. Okay.